Good afternoon, everyone, and welcome to the session. A special thanks to you all for sharing your Friday afternoon with us, last session of the day. Thank you very much. We are excited to show you how we are enhancing coding agents to make smarter and agentic approach to CI/CD, continuous integration, and continuous deployment. I am Haroon Chaudhry, Engineering Manager for Developer Connect at Google Cloud. Joining me today is Yeshwanth Gunasekaran, our technical lead. He will be leading us through demos today. By a show of hands, how many of you are using generative AI on a regular basis? A big number, and that is reflective of the massive change we are seeing across our industry. According to a recent DORA report, 90% developers are using AI on a regular basis. But what happens when that brilliant AI-generated application is ready for production? It is natural to expect that coding agents can help deployment as effectively as they can help with the coding. Still, we are seeing almost 60% of developers face issues when deploying their applications, even when using coding agents. So what happens? Why the gap? Because designing a robust and secure CI/CD pipeline is not about just writing a script or generating a script. It is about navigating a complex and fragmented ecosystem. So how do we help our developers bridge that gap and cross the last mile to production? AI assistants must evolve beyond code generation to address the entire software development lifecycle, including building, testing, scanning, and deployment. To address that same gap, we are excited to announce our CI/CD extension. It empowers developers and platform engineers by pairing models intelligence with their specific code base and cloud infrastructure. You can use natural language right within your agents to design, build, and deploy your CI/CD pipelines. It reduces friction and streamlines production, paths to production for cloud runtimes, including Google Cloud Run and Google Kubernetes Engine. Today, it is available both as Gemini CLI's extension as well as Claude Code plugin. By leveraging standard primitives, we have ensured that this is harness agnostic and can be adopted to a tool of your choice. So, Yash, are you ready to show us how this works?
Absolutely. Thanks, Haroon. Next slide. So, under the hood, our extension consists of 4 major components. First, we have skills. These extend our agents' capabilities with predefined workflows and knowledge. We have built-in skills for designing and deploying CI/CD pipelines, to manage infrastructure, and to achieve many common CI/CD tasks. Second, we have a local MCP server, or Model Context Protocol server, that runs with the user's credentials and helps agents manage Google Cloud CI/CD tools. Third, we have a local knowledge base that has packaged all the CI/CD best practices, common deployment patterns, and curated documentation for Google Cloud's CI/CD tools. And finally, we have evals. For every release, we run a comprehensive set of evals on many common OSS and custom-built projects. We test for common deployment and design patterns. We are committed to investing into our skills and expanding our eval set as we add more features. And finally, the entire package that you're seeing today, all of this is open source. Isn't that great? we want to build in the open, and we appreciate community contributions. So with all that being said, let's jump into our first demo and see how our CI/CD extension helps with deploying onto Cloud Run. So like I said before, our CI/CD extension works with multiple agent harnesses like Gemini CLI and Claude Code. For our first use case today, let's invoke Claude, and we'll run this demo with Claude. I've pre-installed our CI/CD plugin to help us move faster. And let me show you what that actually looks like. So let me run /mcp. Here you can see that our local MCP server is installed. This comes packaged with our CI/CD plugin. Next, let me run /skills. So here you can see that we have our deploy, pipeline design, release orchestration, and Terraform skills. All of this comes packaged in with our CI/CD plugin. Now, I'm going to give it a very simple prompt to deploy our application. So the expectation is that our CI/CD deploy skill is invoked. There you have it. And then the agent starts looking into my local application infrastructure and then trying to see what's the best path to production. So there you have it. Claude has found out that we are using a Python Flask application, and it's now looking into my gcloud and Git settings to find out more about my environment. So this entire back and forth takes 4 to 5 minutes. So in the interest of time, I've done a pre-run earlier. So let's hop over to that session and look at the logs. So here you can see that I've started off with the same prompt. Our deploy skill is invoked. Our agent then looks at our application to understand more about it and has found that it's a Python-based Flask application. And then we have a couple of options for deployment. We can either deploy to Cloud Run or to GKE. And if you're using Cloud Run, we could use build packs because we have no Docker file in our application. For this case, since it's super simple, I'm going to use Cloud Run and build packs. After that, it's looking at my gcloud and Git settings, like I said earlier, to find out where to make a deployment. Let's zoom past forward.
Yash, I'm seeing over there that it is scanning for secrets. Can you expand on that, please?
Thanks, Haroon. I was hoping you'd ask that question. So before our developer pushes our code into the cloud or our image into the cloud, our extension has certain pre-built checks that it forces the agent to do. One of these checks is looking for hard-coded credentials. So in this case, we have no hard-coded credentials, so we are fine to proceed.
Exactly. So developers don't need to install yet another tool for the integration of secret scanning. Our plugin comes with a tool built into it. And furthermore, it is integrated into their workflow, providing them a secure by default behavior from there. So let's move on, Yash, and see what happens next.
Thanks, Haroon. So next, our agent's going to ask us more questions about our deployment. It's asking us for the region of our deployment and then the visibility of our Cloud Run service. Let's keep it super simple and deploy to US Central 1 for our region and then set our visibility to public. Finally, after confirming all these parameters, our agent makes a deployment and leaves us with a very good summary of the project, region, and the service name. And it's also given us the service URL of our Cloud Run service. So let's go ahead and open that up. And there you have it. We have a working application, all thanks to our extension. Back to you.
Thank you, Yash. A smooth deployment to a shared environment is a huge first step, but it is the beginning of the journey for application delivery. The actual challenge is in designing the application and the CI/CD pipeline for that, and the infrastructure that supports that CI/CD pipeline, along with connecting all of your CI/CD tools that are required to make this whole thing work together. The heavy lifting, the designing, the integration, and maintenance is where the actual challenge lives. In fact, we have seen in many enterprise teams that there are 3 major roadblocks that they encounter when they're designing and implementing their CI/CD pipelines. Let's take a look into those friction points. Most enterprises use best-of-the-breed platforms for their CI/CD. In fact, more than a third of organizations use more than one CI/CD platforms. Integrating with DevSecOps tooling is yet another problem. To resolve this, we need a unified, automated integration across the entire delivery pipeline. Connecting your pipelines and infrastructure as code to your live production environments is a tedious and manual process. Debugging your agent-generated pipelines require deep understanding of your application design and infrastructure architecture. That's why almost 3 out of 5 deployments encounter issues when deployed, even using coding agents without additional help. With huge amount of AI-generated code, security has become a major challenge, especially leaked secrets. In fact, according to a recent industry report, the amount of leaked secrets in public repositories has jumped over 30% in just one single year. When infrastructure is complex, engineers often over-provision IAM permissions and sometimes bypass security gates just to get their pipelines to run. Because CI/CD pipelines provide a direct path to your production environments, they now become the prime target for supply chain attacks. These are the factors why we are seeing that AI adoption in CI/CD space is lagging behind. In fact, only 27% of organizations today are using AI for their CI/CD workflows. That means over 70% don't. To address infrastructure and security hurdles, AI agents must shift from code generators to integration orchestrators. And that's exactly what our extension brings to the agent. Our extension bridges the code versus cloud gap by working and operating within your workflows, grounded in your code base and your Google Cloud environments. Rather than producing templated pipelines, it actually acts as a supervised drafter, helping you connect all of your CI/CD tools, author secure by default pipelines, and configure your deployment environments. Let's take a look at how our CI/CD extension simplifies designing and implementing an entire CI/CD pipeline. Yash, are you ready for the demo?
Absolutely. Thanks, Haroon, for highlighting the real-world challenges that come with deploying to production. As we've seen before, deploying to production isn't just about deploying to a single service. It's a complicated dance between deploying to multiple environments, having the right production approvals, and having all the safety nets. Let's see how our extension can help with this. So for this demo, I'm going to be using Gemini CLI. Let me go ahead and invoke Gemini. I'm going to run /extensions list to show you that our extension is installed and active. Next, let's give Gemini a high-level architectural goal. Design a CI/CD pipeline for my application with multiple stages. The pipeline must also automatically roll back deployments on failure. And let's use Cloud Build and Cloud Deploy for this use case. The expectation is that Gemini automatically invokes my pipeline design skill and then goes from there. There you have it. So our pipeline design skill is invoked. So this has all the best practices and multiple patterns built into it. Next, a release orchestration skill, which has all the best practices of building cloud deploy pipelines. Let's allow that. So again, this is going to be a back and forth process where we work with Gemini to give it the exact requirements of our pipeline, and then Gemini comes back. So this could take around like 6 to 8 minutes. So in the interest of time, I did a pre-run earlier in the day, so I'm going to switch over to that. So as you can see, I've started off with the same prompt. Gemini has then loaded our pipeline design skill and our release orchestration skill, just like before. And then Gemini asks me strategic questions to find out more details about the pipeline that I want. For the runtime type, I'm going to choose Cloud Run because we have a very simple pipeline. For the trigger type, I'm going to choose a push to main strategy. So this invokes our CI/CD pipelines when our code gets pushed to our main branch. And finally, I'll leave it with more details about our project ID, the region in which we want our CI/CD pipelines, and our application name itself. Next, Gemini asks me about my deployment strategy. For this one, let's keep it really simple. I want a deployment on a staging and prod environments, so I'm going to stick with a standard multi-stage deployment strategy. Then, Gemini acts as a consultor and generates a plan for us. This plan has the objective that it wants to achieve, key files and context that it's actually looking at, and gives us all the implementation steps that it's going to follow. So here's where I would work with Gemini to tailor the CI/CD pipeline just like I want. In the interest of time, I'm going to zoom past this and I'm going to accept the plan. So once the plan is approved, Gemini now moves from a consulting role to implementation. It's going to start creating all the required files for my CI/CD pipeline. First, it starts off with my Docker file for my Flask application. And here you can see that we have a multi-stage Docker file that's being generated. This helps keep all our build dependencies out of our production binary. Let's zoom past that. Then Gemini starts generating all the required files from a cloud deploy pipeline. It's generating our staging.yaml file for our staging environment, our production.yaml file for our prod environment, and finally the required scaffold.yaml, which cloud deploy requires. Then it's moving on to create the cloud deploy YAML itself. This has our end-to-end pipeline and how and wires up our environments.
Yash, I know many enterprises have strict production governance and gates around that. How is this pipeline going to address that?
That's a good question, Haroon. So Cloud Deploy, by default, supports gating deployments to production environments. And these best practices are built into our extension. So here you can see that our extension has guided our agent to set require approval equal to true for our prod environment. On top of this, our agent has also correctly set all the rollback rules. So these set of rules make sure that whenever there's a deployment failure on either staging or prod environments, we automatically roll back.
So that's important. It is not about doing blind deployments to the production environment. It is about understanding your governance gates and automating them in the pipeline design so we can meet the security requirements and governance requirements. Yes, let's continue and see what happens next.
Next, our agent does the heavy lifting. It creates the required infrastructure resources, like creating the Artifact Registry repository to store all our Docker images for our CI/CD pipeline.
Yes, now it has created the cloud resources, for example, Artifact Registry. I know setting the IAM permissions is a huge challenge that we would have. So how is our extension handling that challenge?
So this is the beautiful thing about our extension. We have built in all the roles required for all of Google CI/CD products into our extension, so it automatically takes care of provisioning dedicated service accounts and making sure all the IAM roles are correctly set. So if I scroll down here, you can see that it creates dedicated service accounts for cloud build, and it also makes sure only the absolutely necessary IAM permissions for the service accounts are set.
It is critical. Baking the least privileges in the pipeline design addresses a huge security hurdle, and it reduces the risk and exposure to supply chain attacks. Let's continue to the next one.
So next, Gemini moves on to creating our cloud build.yaml files. So this is what defines when our CI/CD pipelines get invoked and what they do after they get invoked. So first, our CI/CD pipelines build our container image from source. Next, they push to Artifact Registry repository that we created earlier. And finally, it creates a cloud deploy release with the image that we just built.
Yes, now that we have all the YAML files and the configurations and GCP resources, how is the extension going to help with connecting our Google Cloud services with our source code in GitHub?
So the recommended way to connect our source code management systems to Google Cloud is to use Developer Connect. And these best practices are again built into this extension. So if I scroll down, you can see that our agent's looking to see if there's an already existing Developer Connect connection, and it's going to leverage that in the case that it exists. In our case, we already have a pre-existing Developer Connect connection. So once it finds that, it's going to next see if it can use that particular connection to connect a particular repo.
So this is a good example of orchestration and integration. So it reduces the manual friction of connecting your source repository to your cloud services, and it reduces the time and effort required to set up your pipelines. Let's continue.
So next, it's going to apply a cloud deploy YAML file that we created earlier on, and this creates all the required resources on GCP for cloud deploy, like the cloud deploy pipeline and various targets for our environment. After that, we move on to creating the build trigger itself. So in the highlighted section, you can see that we're reusing the same Developer Connect connection that we found earlier on. Our CI/CD pipelines are set to trigger whenever there's a push to our main branch. And finally, it's using the same service account that it created earlier on. Then Gemini moves on to making sure all our resources exist as expected. It's using the describe commands to make sure all the required resources are created. In the interest of time, I'm going to zoom past this and move to the end. So finally, Gemini leaves us with a very good overview of what all happened. We have our end-to-end pipeline architecture that Gemini created for us, the key files that it modified, and then all the resources it created, like the Artifact Registry and the build trigger.
Thank you, Yash. It's great to see all the integration and linking with the third party all set up with proper security defaults. Now, Yash, there are many teams who believe that if it's not in Git, that infrastructure does not even exist. So can you convert this entire setup into infrastructure as code?
I was waiting for that question. So I've done a pre-run this morning with the same prompt with the additional text to generate Terraform, and we have built-in skills to help with infrastructure as code or Terraform. So let me hop over to that session. So here you can see that we've started off with the same prompt, and we've just added the generate Terraform text. Next, our agent goes through the same process, invokes the pipeline design skill, and this is the new part, right? It also invokes our CI/CD Terraform skill. And this has all the best practices for creating Terraform for our CI/CD tools. Now, after this, it's going to be the same back and forth where I talk to Gemini and craft the pipeline exactly to my needs. In the interest of time, let's skip that and actually look at the generated Terraform files. Before I jump into Terraform, you can see that the same files for Docker, for Cloud Build, and Cloud Deploy are generated. And then it's put all our Terraform assets into our Terraform directory. let's view main.tf. First, it started off with creating our Artifact Registry repository to host our Docker images. Next, our agent creates all the required service accounts for Cloud Build, Cloud Deploy, and Cloud Run. Then, our agent sets the required IAM roles for our Cloud Build service account and service agent. Let me scroll past that. Next, our agent sets the required IAM roles for Cloud Deploy. Then our agent moves on to creating our Cloud Build trigger. And here you can see that our push to main branch configuration is correctly set and is also reusing the same developer connect connection that already exists. Let's scroll down. And finally, our agents generated the required Cloud Deploy assets like the delivery pipeline. It also has set 2 stages, just like our prompt asked for. So staging and production. Let's go to our production resource. And here you can see that it's also set required approval equal to true on our prod environments. And it's automatically set the rollback rules for our staging and production environments so that rollbacks can happen when things go wrong. So we've gone from almost nothing to a production grade CI/CD pipeline in a matter of few conversations with the help of our extension. Back to you, Haroon.
Thank you, Yash. So we have seen that how our CI/CD extension actually works inside Gemini agent, and it transforms a complex, fragmented process into a smooth conversation with your agent and guides the user through design and implementation of your CI/CD pipeline. That concludes the core of our presentation today. Before we go into questions, I would like to emphasize one more time that this is an open source project. And we have QR code for our GitHub repository. We have also set up a code lab for you to try this in your own environment. Please give it a try. Open an issue for us. Let us know what you want us to integrate next. Or even better, send us a pull request. We really appreciate your contributions.